Okay, in this video, what we're going to do is we're going to play with power. We're going to increase our power, and we're going to do so assuming that we have two groups within subjects, and we're going to see how that changes things with the dependent t-test. So this is just like we did with the independent t. I'm going to increase the between group variance. So all I'm doing is adding 30 to the original scores, and you can compare this to the first dependent t-test video. And you'll see that this is the only group that changes. And if we do that, the within group variability is going to be the same, but our difference between our groups gets much larger. So let's look at what happens. So here's our D score. Remember, we get midterm minus final. There's your D score, sum of D. And then, of course, 160 squared is this. We still have 5. And then we're going to square each of these values and sum them up. Now you just substitute into the formula. Hopefully you're not confused by that. And we're going to solve our standard deviation and then divide by the square root of 5 to get standard error of the mean. So this is what we're doing when we do this. So the last step here is 10 divided by 2 here. And you see the numerator gets much bigger. And also notice how our denominator is much smaller than the independent t version, right? That's the big difference between the independent and dependent t tests, is the denominator is much smaller because you have that D score. You're taking out subject variability. I should have mentioned that in the previous video, but you're taking out subject variability, so you're really focused on the difference measure between those two values. So here's our t ratio. We look it up. Here's our critical t, and of course now we're rejecting the null hypothesis because we have greater power. Let's do the same thing by decreasing the within group variance. So I did this. This is the same data that we did in our independent t-test example. So the between group variability is the same as our first example, but much smaller variability within the groups. Here's your D value, right? Plug them into the formula. Now notice that the numerator is the same, but the denominator is really, really tiny here. It's very small because we squeeze down the within group variability, and it's also a dependent t-test, so that takes out subject variability. So it's the smallest of all of them, and we end up with our t ratio. We compare it, and we're going to reject the null hypothesis there. So what it does is it crushes down this within group variability, and that ultimately boosts our t ratio. So that's how power affects the dependent t-test. And again, use these examples to make sure that you're understanding how